Hi, my name is Kolton Andrus. I'm the CEO and co-founder of Gremlin, a company focused on helping companies build more reliable software. Prior to founding Gremlin, I had the opportunity to work at Amazon and Netflix, where I got to observe a lot of best practices and some not so best practices. And I got to see different teams and different size and scale of software. And one of the things I've learned is, the number of nines, it's not the same for everyone. Not everyone's Netflix, not everyone has the same requirements. And so I want to walk through a bit of what life is like at each nine at a high level and what you could do to improve to make it to the next nine. So in the beginning, we're in a 2-9s world. Things are breaking often. We have days of outages. Our customers are likely unhappy. Our engineering team is likely unhappy. We're not satisfied with the software that we're shipping because we're seeing failure and we're seeing issues. In this world, it's typically smaller teams, younger companies, or earlier versions of services, and it may be one person's life. We probably don't have a dedicated SRE team or a broader operational purpose. Instead, we essentially have Brent. For those of you familiar with the Phoenix project, I think Brent typifies this. The hero that's willing to, take care of the issues when they arise, the person that has all the context, but ultimately and ironically, the bottleneck from really improving the organization and improving the reliability of our software. And so in this world, we might be doing some logging, but we're probably not doing monitoring. And akin to driving a vehicle or flying an airplane, that control panel is critical for understanding how the system is behaving. We've done some testing, but if we really embraced the best practices that we as an industry have learned over the last decade or two around build and deploy pipelines, around consistent testing in those and consistent deployment. Redundancy becomes important. Do we have backups of our services, of our hosts? Can we handle a zone failure? And what does our incident management process look like? Or do we have one? And this is a great opportunity, even in the beginning, as a small step to ask ourselves, what do we expect? What are the roles and responsibilities that are important? And how can we help our teams prepare for when things go wrong? One of my favorite jokes with a live audience is to raise hands and say, who has actually received on-call training? Because the answer is not many of us. Mine in the past has always amounted to, here's your pager, good luck. You're smart, you'll figure it out. And I think this is us doing a disservice to our teams. There's a reason that we've all grown up and participated in fire drills. And that's because if a fire breaks out or something goes wrong, we need to be able to respond quickly and calmly and safely. We need to know what to do. We don't want people running around with their hair on fire, panicking. And the same is true when it comes to resolving incidents in our production systems. If we haven't had an opportunity to practice and prepare, then when that panic and that adrenaline hits, when we know that things are broken, people may not respond in the way that is correct or in the way that they know. And so, in my opinion, this is a great opportunity to apply some very easy chaos engineering, to be able to go in and to be able to test that your alerts and your monitors fire the way that you expect, and be able to baseline your team's response. This opportunity to go out and to run a game day, to run a fire drill and see how your teams and your systems respond will just allow you to build a little bit of comfort, to review your process and to make sure your teams know how to respond. All right, so we've done some basics, we've got some alerting and monitoring, we've got an incident management process. Our company's grown, our service has grown. What does the world look like today? Well, the 3-9s world, honestly, is where most software companies are. There aren't many that are at the 4 and the 5 nines, and this seems to be kind of the 80-20 you observe in the industry. Failures might happen, but they're not happening that often. 8 hours over the course of a year, less than an hour a month, maybe spread across an incident or two, can feel like it's not that big of a deal, but when it happens, our customers are still annoyed. And if we're on a service that they have an opportunity to go and use a competing service, they might just do that. People have become somewhat impatient, and if they're unable to use your service right away, you may be forcing them into the arms of a competitor. In this world, we probably have moved past just one person's problem. And the critical teams that are running the important services have been forced to prepare and to get better at this. And likewise, we're starting to capture our learnings. We're talking through past incidents, past outages, and it gives us an opportunity to share that and to better understand what has occurred and what could occur. So this is really where I see a lot of companies where we have an SRE team. We've invested in reliability, in the process. You know, they may not be part of every team, but they're there to be able to help and guide those teams that are doing the work on their own. And so we have logging and monitoring, but one of the ways the pendulum can swing is we can have too many alerts and monitors. We can end up with a lot of noise and not enough signal. And so it's important to be able to go tune our threshold to make sure that when something does fire, it's informative or it's actionable. We're doing a better job building and deploying, and code is going out more and more frequently. And so how do we keep up with this pace of innovation? Well, we need to be thoughtful about doing things like canary deploys so that we're testing real world environments. And we need to be thoughtful about not just the happy case, but the unhappy cases. And so thinking about those edge cases and what happens when a dependency we rely on fails or a database slows down helps us to foresee things that could go wrong and prepare for them. In the 2.9's world, you know, we got good at doing some incident reviews, but the learnings were isolated. And in 3.9's, you see a bit of that. So if we really want to improve, we have to take what we're learning and the outcomes of that and share it across our whole organization. There's an opportunity to help someone else not have the failure that you had by sharing what you learned and working together. And in this case, you know, maybe we focused on having host level redundancy or zone level redundancy, but now maybe we need to look at regional redundancy. What happens if a cloud provider or one of our data centers goes down? Well, we need to be able to route traffic. We need to be able to spin up backup services. And to me, this is an important one to be able to test. Having lived at Netflix while they were heavily practicing their region failovers, in the beginning, it was a manual process that took a lot of teams and several hours or days. And in the end, it was a 5-minute automated process that could be done over chat. But the key was to continue to iterate and improve by practicing it regularly and to continue practicing it, because every other run, there'd be some new bug or error introduced that would stop it. And there's nothing worse than thinking that you have a mitigation in place, an outage occurs, and that doesn't work, because then you have 2 outages that you have to deal with instead of the big hammer that solved the problem. All of the systems we're building today fundamentally are distributed systems. And distributed system testing and verification is tricky. It's harder than your classic unit and integration tests. And so we need to be able to go out and prepare for what happens when something that you rely on fails, whether that's a public cloud service, whether that's an internal identity service, whether it's a database or a third party or a vendor. Unexpected failures can cause your system to fail. That can cause your customers to have a bad experience. And your customers won't care that it was your dependency that went wrong. They will care that your service didn't operate the way that it should have. And so we need to be more thoughtful about going out and identifying these dependencies, making sure we're aware of them, and understanding what happens if something goes wrong. All right, so now I got a taste of this world at Netflix. We were able to hit 4.9s. And there's some interesting behavioral aspects that come into play. Outages become less frequent and people get comfortable and complacent. And so ironically, as we get better at outages, it becomes just as important to keep practicing them so that we don't get complacent, so that we don't get surprised, so that we don't feel like the system's fine and then a huge outage occurs. In the 4.9's world, customers really aren't seeing failures. And ideally, the failures that are occurring are being mitigated very quickly, or we have ways to gracefully degrade so that the customer is able to do the core business function they're there for, and maybe the ancillary one doesn't work or disappears. In this world, our teams are better prepared, and so they're spending more time on feature work. They're not being interrupted. They're not being woke up in the middle of the night. They're not losing their next day's focus because they were interrupted in their sleep or because they're deep diving into logs and piecing together a timeline. And they're also benefiting from the learnings of this deeper understanding of their systems. By running these experiments and really understanding how the system responds and behaves, they're able to take those lessons back into the engineering that they're doing and build better quality early, build better software and test it earlier, reducing the cost of changes and improving the quality. And in this world, we've taken all of the learnings and the incidents and the outages that have occurred, and those are informing our engineering best practices. They're part of what we're teaching our teams, and we're sharing that context broadly in a way that isn't about blame and isn't about finding out who's wrong. It's about helping prepare the team and making them aware of what can occur and how to handle it when things go wrong. And to me, this is really what we're striving for, is a culture of resilience. In the 2 9's or the 3 9's world, it's a person's problem. It's a team's problem. It's not everybody's problem. But the truth is, for the complex distributed systems we're building, reliability is everyone's problem. Everyone needs to be thoughtful about it. Everyone needs to participate. That doesn't mean everyone needs to spend all of their time on it. In fact, as we decentralize it and amortize it, everyone can spend much less time in aggregate, and we can reduce the pain that our teams and our customers are feeling. So the 4 9's world, where do we go from here? Well, observability is ubiquitous. We can measure all the things, we understand all the things. Now we can get into analysis. Let's detect things that are behaving oddly more quickly. Let's begin to dive into the subtleties and those unhappy cases to see what happens. We're doing unit testing, integration testing. We've added performance testing and failure testing into our build and deploy pipeline so that we know that the code we're shipping is at the least not regressing and that we're holding that bar. Now we can look at canary deployments and regional rollouts. We can think about how we distribute data and configuration changes as well as new software changes. As I've seen a number of outages because somebody changed a global property that didn't behave the way it expected. And the opportunity to be thoughtful about isolating those changes, canarying them and rolling them out helps to mitigate that additional risk in the system. In this world, we're doing game days, we're doing blameless postmortem, we're running fire drills, we're giving people an opportunity to practice, to ask questions, and to understand how the system will behave. And we just need to continue doing that. As I mentioned, there's an atrophy that comes and a complacency when things appear to work well and our system feels rock solid, so we can take our foot off the gas. And truthfully, we just need to do that maintenance to make sure that we're staying on top of things and not going to be surprised. And we're region redundant. We're probably running an active architecture so we can fail over at any point. At this point, we can start to consider, do we need multiple cloud providers? Do we need multiple redundant third-party services? So if one goes down, we have another way to fulfill that. And this becomes a cost benefit and a risk analysis of it's more expensive and more time intensive, and it increases the complexity of our software, but it may help guard against a very large and impactful outage. Again, coming from Netflix and knowing there was a day that AWS had an outage and Netflix was down in 2013, while unlikely, these black swan events can and do occur. And we want to be thoughtful about if it's going to have a substantial impact to our business, to our customer trust, to our revenue, it may very well be worth investing in preventing that. So in this world, it's really stressing. There's a lot of different things. We take DNS for granted. We have these peak traffic spikes. Our own internal networks can be degraded. A cloud provider can fail. And so in this world, we need to be testing in production. We need teams to be testing on a regular basis. And really, it's this weekly cadence that teams are able to make sure that they're validating these assumptions and that their systems continue to operate well. And then 5 9's, this is the world we love to be in. We want to be like the utilities, like a water faucet, like the power. When you turn it on, it works, and that's what people expect. And to get to that world, our systems need to gracefully degrade. They need to self-heal. If we have 5 minutes of downtime in a year, people really can't be involved. We have to be able to mitigate most things in the fly. Even if that doesn't completely solve it, we need to be able to remove the customer impact so that a person can take care of it. And this really becomes about just good, efficient engineering. Again, if this is everyone's problem and everyone's thought about it and everyone's investing even a small amount into it, then we're going to be able to have this qualitative shift in our platform and its reliability. And we're in this world, not only are we sharing everything, but we're excited about it. We're exploring, we're talking about what's coming next. We're thinking about new and different ways to approach reliability and the quality of our software. This is the future. I have another version of this where I had a slide which has a troll face in it, because in some regards, this is highly aspirational. The complexity of our systems makes this very difficult to achieve, and it may not make sense for our businesses to invest the kind of money and time and effort to get to this point. And so depending on the size of your team, if you're smaller, if you're earlier on, maybe you're not on the front door of your service, of your company's product, but maybe you sit a tier back or two, then you might be able to take some of these tips and tricks in order to reduce the pain you feel and improve your software without needing to go all the way to the 9’s world. So hopefully that helps provide you with some context and some trade-offs of what happens. And thank you very much for the opportunity.